Okay, increasing and decreasing functions. You have a fact, which is right at the top of that page. If the function is increasing, then f dash x, that's the first derivative, would be greater than 0. If the function is decreasing, then that first derivative, f dash x, will be less than 0, okay? So let's have a look at the first question. So it's got y is equal to x cubed minus 6x squared plus 2x, take away 1. Determine if y is increasing or decreasing. That's going to require us to calculate the first derivative and then substitute in that value of x at that point to determine whether it's positive or negative, okay? So let's do that. So we've got dy by dx. Bringing that 3 down in front, you'll have 3x squared, take away 12x plus 2. That's differentiation, isn't it? Bringing that 2 down in front gives you the 12, and then reducing that 1 to the power there, isn't it, by 1. So we'll go to the power of 1, and 2x will go to 2, and that minus 1 will disappear. We now need to put the value of 2, because that's the x value they've given us there, into this expression. And that determines whether it's positive or negative. So it is minus 10, it is a negative value, and therefore we would say this is a decreasing function. Okay, example 2. So the range, or find the range of values of x for the function f of x is equal to 4x squared minus 20x plus 6 is decreasing, okay? So we need to find the range first of all. So the first thing we want to do is think about the first derivative, okay? F dash of x. If we do that, you bring in the 4 and the 2 together, that becomes 8. X to the power of 1, isn't it? So just x, and then take away 20. So that's our first derivative. Now, as an increasing function, this derivative would need to be greater than 0. So that's the first thing we will look at doing. Getting x on its own is then a basic GCSE, taking your minus 20 over the other side. So x would be greater than 20 divided by 8. So x is greater than 2.5, and you would say the function is an increasing function at that point. The other side we will look at is the decreasing part. So we say x minus 20, the first derivative, is less than 0. And again, we'll do the same thing. We're going to end up with the same answer, just a different symbol, isn't it, in front of it. So x is going to be less than 2.5, and that would be the function is decreasing at that point. So therefore, we have our range of values. Okay, third example then. So find the range of values of x for the function f of x is equal to 2x cubed minus 3x squared minus 36x minus 217, and prove that it's an increasing function. So again, you're starting in the same place you find in the first derivative, or dy by dx, isn't it? So if we do that, we're bringing the 3 down in front, so it becomes 6x squared, reducing the power by 1. Bringing the 2 down in front, so again 6x to the power of 1, and then take away 36, okay? Now at that point, I would probably divide by 6. Everything goes into 6, doesn't it? To make it a little bit nicer for ourselves. So we will have x squared take away x minus 6. Now that is a quadratic expression, therefore we now need to think about factorising it to get our two values of x. So hopefully you'll know how to do that or have a method. So x times x at the front will give you x squared. Two numbers that multiply together to give 6, that's on the end, isn't it? So we could have 6 and 1 or 3 and 2, and one of those pairs has got to make that 1x in the middle, isn't it? So it's got to be 3 and 2. That has a difference of 1. Now we do need to make minus 1, so that needs to be negative, and then you're going back up 2 on the number line, okay? So applying your either or, you're taking the opposite of what's inside those brackets. Those are our two values, aren't they? Now in order to determine it's an increasing function, we now need to substitute those values, each one of these, into the first derivative, okay? So we say when x is equal to 3 first, we do the positive one. So every time in here we see the value of x, we are now replacing that, aren't we, here? Okay, so that's going squared, take away 3, and then take away 6. So if we work that out, that's what we've got so far, isn't it? So 9 take away 3 is going to give us 6, and then 6 take away 6 is that 0 value there, okay? Now the other thing we want to think about really is what happens when we substitute in that value of minus 2. So that's the next thing we need to put in. X is equal to minus 2. So now we've replaced the same thing in there, okay? So every time we see the value of x, we're now going to put this minus 2 into play. So that would give us 4 plus 4, and then take away 6. So it's 8 take away 6, which is 2, isn't it? So that's a positive value, okay? So we can prove that we have an increasing function, as f of x is going to be an increasing function because we have that positive value when we're dealing with that derivative point, okay? And obviously when we're dealing with then our sort of inequalities, the range of values, we say x has got to be less than minus 2, and then x has got to be greater than 3 in order for it to give us that increasing function.